Solar electric vehicles. Alan Freeman in England built the first solar powered vehicle in 1979. So solar electric vehicles were quite earlier started and they were in the experiment. Solar powered vehicles capture the energy from the sun through photovoltaic cells as shown into this figure. And they convert this solar energy into electricity, which can either power the vehicles directly or charge the batteries. The World Solar Challenge (WSC) is one of the most well-known events for solar-powered vehicles crossing Australia continent from Darwin to Adelaide, and this is shown into the figure. This is just to motivate and to get the solar electric vehicle and accelerate the solar EV and promote the solar EV. The World Solar Challenge is now held every 3 years and attracts teams from all over the world. And these similar events are held in various countries like Japan, US, Africa. Here, a simple PV where solar is placed on the rooftop of the vehicle is shown here. So various locations can be found and the solar electric vehicle will have solar panels on it to power the motor or battery. Here we can see the conventional solar powertrain as seen into this, as shown into this figure. You can see the solar energy getting on the solar panels or photovoltaic cells. If you see the indications, B is the battery pack, D is the motor drive, G is the reduction gear, M is electric machines, that is the motor, MPPT is the maximum power tracking, and PVC is the photovoltaic cell. So here we can see the battery is connected, solar PV is connected to the battery, and then it is connected to the DC to AC converter. And after suitably converting into AC voltage, which is well suitable to the motor, is connected to given to the motor, and then the motor will drive these wheels through suitable reduction gear because the motor may have the high speed and it has to be reduced to the suitable lower speed. So reduction gear is required. Thus, a conventional solar powered powertrain is shown into this figure. The solar energy harnessed from the sun first converted into electricity by solar panels, and then the electricity directly powers the traction motor, which drives the vehicle forward. The conventional solar powered powertrain is easy to implement and operate, but it has a short driving range, a limited acceleration capacity because of the power range, low efficiency, and is highly sensitive to weather conditions because solar PV will operate on the solar radiations. So if the solar radiations are changing, then the output will also change, means based on the weather condition, radiations are also changing. Now the second figure shows a MPPT based solar powered power. Here we can see the maximum power point tracking system, that is MPPT, is placed here. So the solar energy which falls on the solar panel will be given to the MPPT, and then the MPPT can charge the battery, and also the MPPT is connected to the DC to AC converter, which is connected to the motor and to the reduction gear to reduce the suitable speed, and then it is given to the power train, that is given to the wheels, that is the axle. So here again the notations are given, that is for battery, converter, motor, and gear. Earlier configuration was a simple conventional powertrain with solar PV. Now here, rather than connecting a simple solar panels, the MPPT is used to connect the solar panel as shown into the figure. The purpose is to maximize the power generation from the solar panels at various irradiation level as shown into the figure. MPPT is an output variable electronic DC to DC converter which constantly tracks the output from the solar panel, compares it with the voltage from the battery pack, and prepares the optimized voltage to deliver the maximum power to the battery pack as shown here. So it is to optimize the voltage and deliver maximum power to the battery. The power from MPPT can power the electric machine directly, and the power surplus can be used to charge the battery pack here as shown. The energy stored into the battery pack can be used to assist the powering the vehicle when the power obtained from MPPT is low or when the weather is cloudy. So battery will also support here when MPPT power or the power given by the PV solar photovoltaic is lesser. So battery can be the supportive one here in addition to this solar generation. The another configuration is solar powered powertrain with in-wheel motor drive. Here you can see the solar power where solar energy is again converted into electrical energy using the MPPT, and also it is fed to the motors. Also battery is there. When excess power is there, it will be given to charge the battery. Now the change here is the motors are not separated, but they are in the wheel itself. So the purpose is to increase the efficiency. Whatever losses are there due to the gear connections and losses into the transmission can be reduced because of the connection of this in-wheel motor. So the change can be further done to improve the efficiency using the solar PV. As shown into this, the notations are again the battery pack, MPPT, and D is the motor drive, which is connected here. And we can convert it into, it can give directly to the in-wheel motors. So figure shows a powertrain configuration for solar powered vehicle, in-wheel motor drive, the vehicle directly, which improves the efficiency and removing the transmission. The overall efficiency of the powertrain also gets enhanced, gathering the kinetic energy from the regenerative braking. So the purpose of this machine is to get regenerative braking. The challenges in solar powered electric vehicle is the efficiency. The solar PV has lesser efficiency, hence the overall conversion is also less efficient. And it is also based on the availability of the solar radiations. The second challenge is energy storage. Large sized storage requirement is there for the PV energy to provide the continuous long range. The third challenge is practicality. Availability of sun in some countries is not possible, and also the variation of the solar energy is also one more challenge. So wherever there is no availability of the continuous availability of the sun, it is very difficult or it is not possible to design the solar powered electric vehicles. Solar powered charging station. Solar electric vehicle is currently is not practical for everyday mobility. So there is problems related to the variation. There is problem related to the availability of the sun. So feeding directly from the sun to the vehicle is very much difficult or it is practically not feasible. Instead of being installed on board, solar panels can be used at the charging stations, at home, in parking lots, or wherever it is possible. And this can be used for converting the solar energy into electrical energy. And this energy can be used to charge the vehicle. So a solar power charging station is one of the best and most feasible option to use the solar energy for electric vehicle applications. Figure shows a parking lot being transformed into a solar powered charging station. So here a solar powered car is shown that is charging with this solar powered charging station. So this is the solar energy. These are the solar panels. Energy is given to the battery pack. It will charge the battery with the solar energy. Then with the suitable conversion, that is AC to DC, it will be given to the charging station. And after this, it will be given to the vehicle. So how it is shown is the plug-in to the charging station to charge the electric vehicle. The next application is the electric bicycle. The affordable, efficient, and convenient electric bicycles now play an important role in electric mobility. Battery-powered electric bicycle can be seen in various countries like China, Japan, and other places of the world. Major component of this system include a battery pack where battery is required as a power source, an inverter for suitable AC to DC and DC to AC conversion whenever required, a battery management system which manages the power flow and controls the battery power, an accelerator to accelerate the bicycle, in-wheel motor, drive it, and the important is the electric control unit, that is the ECU. The ECU takes the acceleration signal from the driver, motor's rotational speed obtained through all speed sensor installed into the motor, and battery information to provide the command signal to the inverter. So these are the signals required for the electric bicycle. The energy from the battery pack, controlled by a battery management system, powers the in-wheel motor via the inverter. Some e-bicycles capture kinetic energy via regenerative braking system when rider applies brake. So regenerative braking is the very important feature that can generate the electricity when braking is there or brakes are applied, and it can charge the battery and the range of the bicycle can be increased. Electric bicycles can be driven by either electric machine or a combination of electric machine and the rider. So various modes are provided. Either it is a completely electric mode or it can be having the support of the rider, which can be the pedal assistance mode in addition to the electric propulsion. Here you can see the diagram of the bicycle, electric bicycle. Importantly, we can see the battery pack, which is charged via this charger. Then it is given to the inverter to suitably convert the DC to AC, and this is given to in-wheel motor, or you can say the hub motor. Now here it can see DC is converted to AC, and this can be a three-phase or it can be a BLDC motor. Now the important is the electric control unit that is also connected to the motor, to the inverter, provide the suitable switching commands. It is connected to the battery unit for controlling the battery current. It is connected to the battery management system also. So BMS will uh, take care of the battery voltage and temperature signal. So maintaining the temperature of the battery is the important function of the BMS. Also, the ECU is connected to the accelerator, rider input, pedals, and gears. And this will be connected to the drive wheel directly. So to accelerate the wheel to provide the torque. So this is a simple block diagram of electric bicycle. So in summary, we have seen the electric propulsion system for electric bicycle. The major components of the system include a battery pack, an inverter, a battery management system, an accelerator, and a in-wheel motor and electric control unit. The electric control unit takes the acceleration signal from the driver, motor rotation speed obtained through Hall speed sensor installed into the motor, and battery information to provide the command signal to the inverter. The energy from the battery pack controlled by the battery management system powers the in-wheel motor via the inverter. And also you have seen there may be regenerative braking system to recover the power during the braking and increase the range. An electric power bicycle can have either motor or motor and rider system. Here, power distribution for electrical bicycle is shown. So the total power is there, and that is the power output of rider and power output from the electric propulsion is the two powers, which is nothing but the total power. This total power is used power for hill climbing, then another power to surpass rolling and bearing resistance. So there will be roaring resistance. There may be other forces opposing to the speed of the bicycle. That is the rolling resistance between the tires and the road, and power to overcome aerodynamic drag. Because of the wind flow, there is opposition from the wind, and to overcome this also the total power has to be used. So the total power will be used to overcome the opposing forces and to accelerate the and give the range to the electric bicycle.